Today, we're going to talk about what do we mean when we say data model, and we're going to learn a bit more how to think about what actually needs to be inside our developer portal, which relies on our data model. So let's get started. So first of all, a bit about me. My name is Moore. I'm a lead architect here at Port. You can see my Twitter handle and my email here. So if you want to chat, even after the session, feel free to reach out to me. I come from a software engineering background. Over the past few months, I've given many talks, some with Port, some with CNCF, about introduction to developer experience, starting Kubernetes with developer portals, and a lot of content around the world of Port and platform engineering and developer portals. Aside from that, I love video games, I love bouldering, and I especially love burgers. Everyone in the company know that I'm the guy to turn to for a recommendation. And if you're ever in the Tel Aviv area, hit me up. I'll definitely set you up with something tasty. So what are we going to talk about today? First, we're going to touch about the core pillars of a developer portal. Then we're going to talk a bit about what even is a data model and why should you need one. Then we're going to discuss how to actually define that data model MVP, that starting point. We're going to talk about what is a blueprint, which is a Port component. And we're going to go through some practical examples. First, we're going to create what we call a core model. And then we're going to talk a bit about extending that model. And we're going to show a concrete example of a model extension through creating an API catalog inside our developer portal. So first of all, let's start with the core pillars of a developer portal. So oftentimes I start with this slide and I go through the different pillars and explain them. Today, I thought that I will do something a bit different. So I'm going to go to Port's live demo, which is always open. You can always go to demo.getport.io to take a look. And let's go through the different pillars inside the demo. So we'll start with the software catalog. So here we have the demo. This is the builder page. This is where you actually define that data model that we're going to discuss. And every box which you see here is what we call a blueprint. And we're going to dive a bit deeper into what is a blueprint a bit later. But the idea is that every box that you see here, which is a blueprint, starts to configure our data model and our software catalog. So when we go inside the software catalog, we have all of the hosts of dashboards and reporting that we get from the system and from the information that we've ingested into the catalog. But in addition to that, we can also get a table view of all the different entities that we've brought in according to the data model that we created. So for example, this demo is a bit more oriented towards a microservice architecture. So here we can see the list of services, and we can also see the code owners and the URLs to things such as the GitHub repository or the Slack channel and so on. And the idea is that we can go inside each service, get a complete overview of its information. And also we can see how it connects to other entities inside the portal and inside the catalog. But in addition to that, we can also cover an additional pillar, which is scorecards and reporting. So we have our dashboards for the service here. And we also have scorecards, which allow us to configure a certain set of rules and different categories that define how a proper service should look, or any entity inside the portal doesn't have to be specifically a service. But what this allows to do, this allows us to create a best practice, create some golden rule that we want services in our environment, in our software catalog, in our company to adhere to. And we can actually check how each and every service does according to those standards and metrics. So if we take a look, for example, at production readiness, we can say that this service is at the silver tier because it does not have a chaos mesh tool, for example, but it does have an on-call configured. It does have monitoring links. It does have a rather low number of Jira issues configured. And again, all of these rules are configurable by you. So that is the scorecards pillar. And like I mentioned, we already looked at the software catalog pillar, and we have pages for all of the different blueprints and every different component that makes up our data model. And now if we go and look at the self-service layer, we can see all the different actions that we as developers have the permissions to execute. These are actions that catered to our organizational language, to the things that we as developers usually need to do in our company. So again, this demo shows a variety of examples, but if you imagine the developer portal in your company, I believe that you can probably think of a certain number of actions that your developers keep asking you for help with. That might be creating a new in-house package, scaffolding a new service, maybe deploying a service, adding a secret, creating a new cloud resource, and so on. So these are just examples. And again, inside the portal, the idea is that you can always create all of the actions that you require, that your developers are telling you, hey, we often come to you with this. We often open a Slack channel, a Slack message, or we send an email, or we find you in the hallway and ask you. And this gives you the option to give them that independence, give them that freedom to actually trigger those actions on their own with the proper guardrails. So you have a properly configured form with all of the different inputs that you as the platform engineer decided that fit this use case and this action, and put the proper guardrails and inputs in place to make sure that these actions are the golden path. So they give the developers the best way to consume that service, but it's still in a safe way that won't incur additional unexpected costs, for example, or might cause some issues with bad inputs and so on. So that is the self-service pillar. And of course, Port exists through a web UI and a REST API and a ChatOps interface. So today, this live demo shows mostly the UI interface, but again, you can always go and sign up and start using the API, start using the UI, start using our integrations with tools such as Terraform and GitHub and Kubernetes to bring information into the portal and get started setting up that perfect developer portal for your developers. Okay, so that's it about the different pillars of Port. And today, since we're talking about the data model and the software catalog, we're going to focus specifically about the software catalog portion. And we're going to start with what exactly is a data model. So a data model is a representation of the layout and architecture of the components in your environment and infrastructure. The idea is to actually create that map, create that model that shows how the different components inside your environment, inside your organization, connect to one another and the different dynamics between them. The goal is to make it easy to understand the interdependencies inside your infrastructure and how your software development lifecycle tech stack comes together. So how does a service actually connect to the cloud provider? And how does the cloud provider connect to the billing? And what endpoints does the API of a specific service expose? And so on. And the idea is to actually create that dependency graph that shows you exactly how all of the pieces connect to one another. So why do you even need a data model? Why can't it just be a specific use case and you just put your information in it and you get that visibility and you're good to go, you're off to the races? So what we usually go with and what we have seen from clients is that every organization is a bit different. Everybody does something a bit different. The tech stack differs, the terminology, the architecture, everything's just slightly different. Sometimes the changes are very broad. Someone's using a completely different cloud provider. Someone's using a specific Git provider, and the other customer is using something entirely different. Someone is not using Kubernetes, and someone is using virtual machines. So there are a variety of use cases, and they all require a developer portal. And because all of these different use cases are very different, there is no one size fits all. And we believe that a data model should be configurable and it should fit your use case. And since we believe that every organization is a snowflake, it should have a developer portal that perfectly fits its use case and its architecture and the way that this specific organization works. So the data model is the perfect way to address those desired use cases. So if we're talking about tracking incidents, managing microservices, or resolving vulnerabilities, or any other different use case that you want to tackle with your developer portal, it will all result in a slightly different data model And the idea with Port and its data model is that it can cater to that use case, and it can always be extended to continue covering the different use cases that you might have and that your developers might ask for to push developer experience and productivity. So how do you go about defining a data model MVP? And the most common approach that we usually recommend is figuring out that first use case that you want your developer portal to solve and find the initial blueprints that represent that use case. So remember that our end goal is to give our developers that single pane of glass, that place that they can go to and answer all of the questions as efficiently as possible to drive productivity, to drive developer experience, to reduce the churn. And so the first place to start with is asking your developers, okay, what do you actually need? What are your pain points? What bothers you in your day-to-day work? And then taking that information and turning it into that initial data model, into those initial sets of components that you track inside the portal to answer those questions, to be that single pane of glass. And we do that by implementing blueprints, which we're going to discuss in just a slide or two. And once we have that initial use case implemented, the goal is to continue to extend the data model and implement additional use cases. A data model and a software catalog is an iterative process, and you always keep improving. The requirements from developers and from customers always continue to evolve. And the idea is that the data model can always cater to that and continue to be extended and expanded according to the needs of your users. So what is a blueprint? Blueprints are schema definitions for any type or kind of asset in your software catalog. And these are customizable components which make up the schema of your data model. And all blueprints are made up of properties. So for example, here you can see the service blueprint. And this is a blueprint that we're also going to look at in the example that I'm going to show in a few slides. But you can already see here why this blueprint makes sense, because it has a link to the architecture diagram. It has the README for a given service. It logs the language of the service and also the team that owns that service and that maintains it, and also the repository URL. So this already holds a high quality information, but today we don't have a specific place to bring in. And like we said, blueprints are a customizable resource. So this is just a suggestion or inspiration, but you can always create a blueprints that fit your organization. They don't have to be called service. They can be called microservice. They can be called repository or anything in between. And you can configure them according to your use case. Next, let's talk about how to actually create a core model. So what is a core model? A core model is the initial set of blueprints used for your first developer portal use case. This is the MVP of the data model. And the core model is the starting point from which you will continue to add more blueprints and add more use cases and extend the model. So as we mentioned before, we want to start with an MVP. We want to start with a specific use case, which we want to solve. And the core model is just that. It's that first use case, very precise, very catered to what our developers already know that they need, or we understand as the platform engineers that they need, and that is a pain point for them. And that is the core model. So what we're going to talk about is what we call the SDLC core model. And we're going to explain a bit why we think that is a good starting point and a good core model to start with. So the SDLC core model is a model for the software development lifecycle. And it is very often the most basic starting point for clients and organizations and developers, because we oftentimes see that companies have a variety of microservices. They have a variety of environments. They're deployed in multiple cloud regions and so on. And they don't have that visibility. They don't really know, okay, what services do we actually have? Where are they deployed? What cloud resources are they using? Who is the owning team? Who is the current on-call? And so on. So the core model aims to answer exactly that. And we see that oftentimes the core model answers 99% of the initial questions that developers have. So it is a very effective start point. It's a very effective place to start to drive adoption for the portal and make sure that your developers are actually served and actually gain benefit from using the portal and from going inside port and taking a look at the hosted information. Now, the core model contains 3 blueprints. The first one is service, which we went over before, but we're going to touch on it again. Next is the environment blueprint and the running service blueprint. So as we mentioned before, the service blueprint is used to represent a static code repository and its related metadata for a microservice. Now, we've went a bit over it before, but here are some common properties for the service blueprint. So we have the URL to the service repository, the team responsible for the service, the language, the README documentation, a diagram of the architecture, and so on. And the idea is that the service blueprint actually documents that static code repository with the monitoring links and with the documentation, basically giving you that one-stop shop to understand everything that you might need about a given service, how to use it, how to consume it, and what does it rely on, and so on. And again, since blueprints are customizable objects, we can always continue to extend the service blueprint. So we can add the current on-call, we can add the latest version, and so on, and continue to extend it to create even more valuable information and a more valuable view. Next, we have the environment blueprint. The environment blueprint is used to represent an environment where microservices are deployed and resources are hosted. So today, a lot of companies are cloud native and they use probably a multiple of cloud regions. They use a multiple of cloud technologies. They consume a different variety of cloud resources. And the environment blueprint really helps put that in scope and say, okay, this is my cloud, this is my cloud region, and being able to see all of the resources that sit underneath that environment gives a great host of visibility to understand exactly, okay, what clusters do I have? What services are running inside that environment? What are my costs? And so on. So some common properties for the environment blueprints are the cloud provider. If, for example, we're working with a multi-cloud, or maybe we can document the cloud account, the type of the environment. So if this is a production, staging, test, and so on. And the region of the environment in case we are hosted in multiple regions, or we need to make sure that all of our regions are compliant with our customers, and so on. And then closing up the core model, we have the running service blueprint. And the running service blueprint is where we actually really get the benefit of the dependency graph and the blueprints model that Port provides. So the running service blueprint is used to provide the runtime context for a service running in a given environment. As we've mentioned before, the service blueprint is used to document a static code repository and all of its related information. And the environment blueprint is used to document our different environments and all of the resources running within them. Now, when we combine those two under the running service blueprint, we actually get runtime and context information. So we can say, how is my service in production doing? Or what are its metrics? What is its resource usage? And also add some common properties such as the commit hash of the deployed version, a URL to the Grafana dashboard, the Swagger API reference for the running version, and so on. So this is all very valuable information, especially when we're talking about solving an incident and getting all of the correct information and all of the correct links at the same place in 3 a.m. when we wake up and we need to solve some issue for a client. The running service is the best place to go to do exactly that. So now that we have this core model, what is the actual result? What did we get? So this model provides us with a basic layer of visibility into our services and environments with the proper runtime context. So just to demonstrate how that looks, if we go to this demo environment that I've prepared for this webinar, and let's ignore the API endpoint blueprint for a second because we're going to touch on that in just a few minutes, we can already see that we have the running service, environment, and service blueprints all set up. And we also have some information inside the catalog. Now, again, this information was inputted by me manually, but in an organized developer portal, when setting up port, you will use our ingestion method. So you will use the GitHub app, for example, to bring in the repositories. And you will use our, for example, AWS or Azure exporter or integration to bring in information about your cloud environments. And you will use the Kubernetes exporter to bring in the running services. But now that I have all this information here, what did we actually get? So first of all, we can see all of our services, and we can see the repositories and their languages. And if we go into a specific one, we can already see all of its information, including its documentation for how to use that specific service. And we can take a look at its architecture diagram. And since everything is on a graph, we can also see its running instances. So we can see that the authorization service is running in the test environment, and it's also running in the production environment. And this, again, is the power of the running service blueprint, because this gives us the actual context. We can actually see where this specific service is running and what are its metrics, what is its usage of different resources such as CPU and memory and storage. We can see if there are any specific alerts we might need to take care of. And of course, we can also see the service URL and links to its various dashboards. And we can also see the Swagger API definition. So if a specific user wants to start using that service and consuming it, we can also just try it out directly from port. And as I mentioned, we also have the environments blueprint. So we can take a look at a specific environment and ask, okay, what services do I actually have running in production? So for now, we can see that it's only the authorization service. And if I take a look at the test environment, I can see that I have both the authorization and the payment service running in test. So this, again, is a bit of a different view that gives us a lot of context into what is running and what is happening. And that single pane of glass, which is already very precise and answers a lot of questions that we know companies today do not have a clear answer to. And this is why this is the ultimate starting point, because it already creates a very high quality catalog that adds a huge layer of visibility. So now that we have the SDLC core model, we can start talking about extending the core model. So we need to remember that the core model is just the beginning. It's just that one very precise use case, that biggest pain point that we want to solve for developers to drive developer experience. But now we need to start adding to it. We need to go through that iterative process of extending the data model, adding more use cases, and answering more and more questions through the portal, becoming that ultimate single pane of glass, that one tab that your developers need. So here are some common examples for core model extensions. We could add CI/CD pipeline information, so deployments, builds, service promotions, and so on. We can talk about application security information, outdated libraries, security vulnerabilities, things such as that. We can talk about project management data, tickets, sprints, projects, different components, epics, and so on. We can talk about alerting and tracing data, incidents, alerts, on-call paging, different incidents in a given service, or the history of incidents for a given service. We can talk about FinOps information, how much does an environment or a service or a sprint or a given feature cost. And since we have that very deep layer of visibility, we can actually dive into that information and understand exactly how much does everything cost. And the developer portal is the ultimate place to get all of that financial information, to keep track of costs, and to make sure that we're not overspending or we have some orphaned resource set that could be deleted to save up on some costs. Now, of course, there are a variety of different extensions. And let me tell you just now, the best answer for what should be the next extension you do to your core model is, again, talk to your developers, talk to your R&D teams, talk to them about their pain points, about what they currently have trouble with in their day-to-day, and start solving that together with them to bring them the ultimate tool, the ultimate developer portal. What we're going to talk about now is actually a different kind of extension for the core model, and we're going to talk about the API catalog model. So why do we even need an API catalog? Today, microservices architectures often have a host of APIs communicating with one another. Teams have a variety of internal APIs, all communicating through a variety of interfaces and methods. And tracking those APIs creates a very high quality layer of observability and context. This model extends the software development lifecycle core model with an additional blueprint, which we've touched on just a bit. We've shown it, and this is the API endpoint. So now we're going to dive into it and understand exactly what is the API endpoint blueprint. So the API endpoint blueprint provides a single dashboard for the endpoints of an API. This creates observability and utilizes the additional context provided by the portal. So again, we're always trying to leverage that additional context, leverage that graph that all entities are on. So in order to do that, here are some common properties for the API endpoint blueprint. We can add the latest health check status. We can add the HTTP method. We can add the latest health check response time. We can also add some example responses. We can also add some example requests to make it easier to onboard this service and this endpoint and understand how to use this API. And this is all information that could make it very easy to also identify an error. So if we're looking at the latest health check response time or the health check status, we can take a look at a given API, see, okay, most of these endpoints right now are degraded or just straight up unhealthy. This means that we have some incident we need to take care of, and combined with the automations provided by the portal and the self-service actions, this can all turn into a streamlined and automated process to make it very easy for the on-call to take care of an incident, even if it's 4 a.m. and he just woke up and some customer is having an issue. So this is just a small extension, so we get to the result very quickly. But this just goes to show you the power of small extensions. You don't have to go all the way. You don't have to think too hard about the next extension. You can just straight up add a new blueprint, add some high quality information to it, and already you have a high quality extension of the model that adds more value to the portal and makes it easier for developers to use it and benefit from it. So the API catalog extension provides developers with additional context into the APIs provided and consumed by their services. And this additional information is valuable as a proactive measure to prevent incidents and also to debug and diagnose issues with service availability and performance. And like we mentioned, this also helps you to onboard this API and also prevent code duplication. So if a developer now needs to add a new feature or develop a new API, he might be wondering, hey, do we already have some similar functionality inside the organization? And the API catalog is perfect for that because they can see, okay, this new auth token endpoint seems like what I'm already looking for. Maybe I don't have to develop it. I can just make use of the existing endpoint that we have inside our company. So looking at the result, and again, I'm just gonna take us into the builder page for a second. We can already see that we have all of the blueprints set up. And if we go to the catalog and we look at the API endpoint page, we can see all of the different endpoints that we have in our organization, in our services. And now, again, this is information that I've brought in manually in an organized process. You will take, for example, an open API specification or a Swagger specification file and scan it and insert those entities, those endpoints as entities into the portal, and also set up the health check status and add some information as those health checks run about what was the latest response time. So you can always keep track of how your APIs are doing. So right now that we can see our endpoints, both in test and production, are healthy and they are doing just fine. The response time seems pretty low and acceptable. And we can also take a look at this from the other viewpoint of the actual running service. So we can ask, okay, what are the actual endpoints that this running service is exposing. For example, we can see the difference between different deployed versions. If, for example, we have the authorization production service running with some feature flags or with some A/B testing configuration, and one deployment is not exactly identical to the other, we can see specifically for this deployment what endpoint does it expose? Are they all healthy? Maybe this version has some sort of issue, and so on. So this is very valuable information for debugging, for diagnosing, and also for onboarding existing APIs, preventing code duplication, and also making sure that all the quality information is in one place and can be used by developers consuming data from the developer portal. And now that we've covered both the core model and the data model and the API catalog extension, if you have any other questions, feel free to ask them. I see that we already have 2 questions. So Anonymous asks, once I have the design of my data model, how can I set it up and manage it in port? So that is an excellent question. And to answer that, let's go and take a look at our data ingestion model. So these are all the different ways that you can bring information into the portal and into the catalog. And in addition to that, in order to set up the model, basically what you need are your blueprints. So you can set up a blueprint either by creating a custom blueprint, by using our templates, which are opinionated sets of blueprints and their related integrations. So for example, mapping the Git ecosystem from your Git provider, mapping your Kubernetes ecosystem, and so on. And you can also use our Terraform or our Pulumi integration to create that data model, to create those blueprints, to create how all these different pieces connect to one another and the properties that exist on inside your data model. So this is how you actually build the data model inside your port. Now, the next question we have is, when I have the data model in place, how do I fill it port with information relevant to my organization? So as I've touched on a bit before, the ingest model is your friend. This lists all of the different ways that you can bring information into the portal. So you can use our REST API, and we have some examples here which are inside context of the specific blueprint. So you can see here fields that are specific to how this specific blueprint looks. You can bring information from your CI/CD. So for example, from GitHub, from CodeFresh, from Jenkins, and so on. You can use our full-fledged integrations such as GitHub and Bitbucket and GitLab, which uses our new Ocean framework. You can bring information from Kubernetes and so on. And as you can see, we have a variety of ways to bring information into the portal. And the idea is that you get started with a core model, you set up those initial blueprints, and you start bringing in high quality information. You keep the software catalog up to date with all of the latest and highest quality information. So that your developers always have that single pane of glass, that best place to get an answer to every question that they might have. And Anonymous asks, in the demo portal, you have upstream, downstream on the services. How are these relationships defined or discovered? So that is an excellent question. You'll notice that the dependency graph or the builder graph has those relations flowing from one to the next. So these basically define the order of dependency between the different blueprints. So for example, if we're looking at running service, above it or upstream from it in the data model, we have the environment and the service blueprint, and relying on it or downstream from it, we have the API endpoint blueprint. So if we go to the running service and we take a look at one of our running services, we can see that environment and service are upstream from the running service, since it relies on information that they provide. And the API endpoint is downstream from it because the API endpoints are providing a functionality for this specific running service. So they rely on it to actually have some context and information. So that is how the upstream and downstream is inferred. Okay, and I can see another question. Can you mirror both upstream and downstream related blueprints? So you can create relations in whichever direction. You can also create self relations. So a running service could be related to itself. For example, if a given running service is reliant on other running services, you can expose that dependency. And now today you can always take properties from upstream sections of the graph. So for example, you can take the cloud provider and expose it on the running service, or you could, for example, expose the type of the environment on the running service. So these properties can go across the graph. Today, they can always only go downstream. So you can take a property from environment and display it on API endpoint, but you can't do the reverse. But we are working on turning these relations, these lines that go from one blueprint to the next, bidirectional, which means that every point in the graph will be able to benefit from information on any different point, whether it's upstream or downstream from it. Okay, so that is all the questions that we've had. And I can see that we're pretty close to the time for the session. So I'd like to thank you all so much for joining the session. Again, as I mentioned before, the session is recorded and the recording will be sent to you and also uploaded to our YouTube channel. In the meantime, you are always welcome to check out our live demo, which is always open. You don't have to insert an email address or anything like that. You can just go in and take a look and become inspired. And also, Port is self-service. So you can just go ahead into our website and sign up right now. If you have any other questions, feel free to send me a message on email, or if you prefer, you can message me on Twitter. And thank you guys so much, and we'll see you in the next session.